Alright. Okay, alright. Time for the minigame. You're going down, sucker.
You're going down.
Oh yeah, well you're going down.
You know that moment. It's you and your friend down to the last minigame in Mario Party. Your stars are equal, and you are within 5 coins of each other. Bonus stars are off, and that means the winner of this minigame wins the entire game.
Come on.
Alright.
Come on.
What? Calculus?
Calculus.
I don't know calculus!
I love calculus.
Well, this is a game for 8-year-olds! Why is there calculus in this?
Ugh.
Calculus Boot Camp. Rules. You will battle in a best of 7 in calculus problems concerning a single topic. You will play mini games before each calculus problem to decide who will get to answer each problem first. If you fail the problem, the opponent has a chance to steal the point if they answer correctly.
This round is inverse trig functions. First round, rock, paper, scissors. Rock, paper, scissors, shoot. Darn!
Alright, so I have to take the derivative of x, arcsine, and negative 2x. So, I know that the derivative of arcsine of x is 1 over the square root of 1 minus x squared. So now, since I'm multiplying a variable on either side of the equation, to use product rule, so derivative of x is 1 times arcsine of negative 2x plus x times the derivative of arcsine negative 2x, which is 1 over the square root of 1 minus, and then negative 2x squared. And then because of chain rule, I have to multiply it by negative 2. So now if I multiply that all together, I have arcsine of negative 2x plus negative 2x over the square root of 1 minus 4x squared.
Winner! Jeremy. Round 2. Dodgeball.
Alright.
Oh, I slipped! No!
Alright, so I have to take the derivative of arctan of 4x squared plus 6x. So the derivative of arctan of x is 1 over 1 plus x squared. So, all I have to do is plug it in. So 1 over 1 plus 4x squared plus 6x, all squared. So if I square everything now, I get 1 plus 16x to the 4th plus 48x cubed plus 36x squared.
Buddy. You forgot one thing, and that's chain rule. So really, it is 1 over 1 plus 4x squared plus 6x quantity squared times the derivative of 4x squared plus 6x, which is 8x plus 6. And that comes out to 8x plus 6 over 1 plus 16x to the 4th plus 48x cubed plus 36x squared. And that is my final answer.
Taking it back, Brian. 1-1. Round 3. Pillow fight. Victory.
Alright, we have the derivative of arcsecant of 2x to the power of 3 over 2. You know, the derivative of arcsecant x is 1 over the absolute value of x times the square root of x squared minus 1. So first, we have 1 over the absolute value of x times the square root of the quantity of 2 plus 3 over 2 squared minus 1 times, because chain rule, the derivative of that, which is 3x to the 1/2. That comes out to 3x to the 1/2 over the absolute value of x times square root of 4x cubed minus 1. However, if you look, if x is negative, and the radical will always have a negative number, which means that the value can never be negative, so the absolute value doesn't actually matter. And that is our final answer.
Unfortunately, that is incorrect. You see, when you were plugging into the equation for the derivative, you forgot to plug in the first x in the denominator. So really, it should be 3x to the 1/2 over 2x to the 3/2 times the square root of 4x cubed minus 1. So then we can simplify this out. So 3 times 2x times the square root of 4x cubed minus 1.
Jeremy strikes back. 2-1. Round 4. Race to the finish. I win! Let's go.
Alright, derivative of arc cosine e to the x, all of that squared. The derivative of arc cosine x is -1 over the square root of x squared of 1 minus x squared. Sorry. So now we have power rule. 2 times arc cosine e to the x to the power of 1. Chain rule. Now the derivative of arc cosine e to the x. We have that over there. So multiply -1 over square root of 1 minus e to the x squared, because of the argument. Chain rule again, because e to the x is in the arc cosine. Derivative of that is e to the x. So now we bring all that together. So that's -2 e to the x arc cosine of e to the x over the square root of 1 minus e to the 2x. And that is our final answer.
Round 5, chess.
Alright.
Your move.
Okay.
Bad move. Not a bad move.
You're a bad move.
Check.
Alright, so. Can't go out of it. So, like, it can't block.
You can't do
Or take
anything.
the green.
It's checkmate.
What?
You fool! You fell for the fool's mate.
No, I'm a fool! My life is ruined.
Okay, so I need to take the derivative of arctan of x times arccotan of x. So I know that the derivative of arctan of x is 1 over x squared plus 1, and I know that the derivative of arccotan of x is -1 over x squared plus 1. So all I have to do is plug it in. So 1 over x squared plus 1 times 1.
I may have lost in chess, but you're the real fool.
Wait, I'm not done yet.
It doesn't matter, because you're a fool. You forgot product rule. In reality, it's the derivative of arctangent x times just arccotangent x plus arctangent x times the derivative of arccotangent x. And that brings us to arccotangent x over x squared plus 1 plus negative arctangent x over x squared plus 1. Simplify that to arccotangent x minus arctangent x over x squared plus 1. And that is why you are the real fool.
Brian takes the lead. 2-3. Round 6, ping pong. 1 ball. You just got fooled, you fool.
Alright, derivative of arc cosecant of x squared. First of all, the derivative of secant x is secant x times tangent x. And the derivative of arc cosecant x, that is -1 over the absolute value of x times the square root of x squared minus 1. Alright, so first we have -1 over the absolute value of the argument, which is secant x squared, have square root of once again the argument of secant x squared minus 1. Now chain rule, secant x squared, derivative of that is, we see there, secant, plug in the argument x squared, times tangent, plug in the argument x squared, and then chain rule again, derivative of x squared is 2x. Bring that together, you get -2x secant x squared times the tangent of x squared over the absolute value of secant of x squared times the square root of secant squared of x squared minus 1. And that is our final answer.
Winner! Brian Steinberg! Boom!
How did you win?
Let's go! I don't even know calculus!
I don't understand.
Yes! Amazing action.